Hi class, this is your professor. I'm Elahe, and we're going to start today by talking about information systems projects, systems development lifecycle, and different approaches to systems development lifecycle. I want you to look at what I have for you on ReadyNet, week 1, and the orientation module that's called Start Here. Alright, let's see what we have here. A list of things that are happening in the world of technology. Now the question is, what is an information system? Information systems are a set of interrelated components that collect, process, store, and provide as output the information needed to complete business tasks. So what I want you to take away from this definition is that information systems are not all about programs and codes. There are programs, there are pieces of hardware, there are people, there are processes, there are decisions. So all these components together enable decision making based on information. What are information systems projects? Information systems projects are planned undertakings that produce a new or updated information system. It's important to know that information systems projects are defined by their timeline, their budget, scope, which is the set of functionalities that the project will deliver, and the quality at which those functionalities will be delivered. We call this triple constraint plus quality. These different dimensions of the projects are interrelated. Means that if you increase the scope, you expand the list of functionalities that you will deliver, that will have implications for your budget, for your cost, and probably for your quality. What do we do as information systems analysts? So I'm going to ask you a question. Imagine that the president of the AITP and ACM club here at the School of IT has approached our class. They want to have a web-based event manager system. That's all they have in mind. A system that allows students to RSVP, to share comments, to request future meetings, to sign up for discussion forums. They have a vague list of requirements. And that's all. What they know is that this is a web-based application and they want a working prototype in 2 weeks. I want you to take a minute and think about activities that you and a group of classmates here in this class will do to deliver that working prototype at the end of 2 weeks. Okay, I hope you thought about my question. Here is the list of activities that I have identified. I want to gather requirements by talking to the board members and talking to regular students. I want to do a conceptual design the interface, design a database, and I want to build an application. I want to do that in ASP.NET, and I want to have my database in SQL Server. I want to test the application, and I want to demo it. This is what I came up with. Your list could be different from mine, but remember, there is no single correct answer. These are all the activities that we do to deliver a working prototype at the end of 2 weeks. What we listed there more or less follows a category of activities that every systems development project will include. We call them system development lifecycle phases. So we want to identify a problem and obtain approval. This is what AITP and ACM president have done for us. You want to plan and monitor the project. You want to discover and understand detail. That's gathering requirements. You want to design the system. I had that on my list. You want to build and test, and you want to deploy. Depending on the project you're working on, you may have to support the system after deployment. We call this SDLC phases. Some projects, they have more of some of the phases than other phases. But all phases in some form will happen. At what order, we don't know yet. We'll talk about that next. This is a traditional approach to systems development lifecycle. It's called waterfall. If you look at the picture, it goes from the top left to the bottom right, one phase after the other. This is a very predictive approach to SDLC. You would choose that if you know your requirements very well, you know your team very well, and you've done projects like this in the past. So you go one phase at a time. This is good because you have a structure. The steps are clear. But disadvantage is that it's hard to go back. So the phases are one after the other. If you're in implementation phase and you think something is not working, you have to go all the way back to design or analysis or planning to identify sources of change and apply required changes. That's called pure waterfall. Now look at this. This is called a modified waterfall. So you still have phases happening one after the other, but you see that there is overlap among different phases. So you start implementation at the same or before your design ends. That helps you apply changes to design if you realize something is not working during implementation phase. This is the more adaptive approach to SDLC. The project is completed through iterations, one prototype at a time. So you do a lot of planning there at the core. Then you go to your first iteration, you do a little bit of analysis, a little bit of design, a little bit of implementation, and then you produce a working prototype. Depending on your approach, you may let users use that prototype. If you do so, that will be called incremental development. So you do one prototype at a time, you do a little bit of analysis, a little bit of design, a little bit of coding and testing and deployment, depending on your approach, during each iteration. The good thing about this approach is that you can apply changes, you can receive feedback, you can change your approach to design or to coding at any time during the development. One disadvantage is that it's not clear what happens next. So you could be in a situation where you don't know what is the end. When is it that you're done? So lack of clarity, lack of structure are disadvantages. But the big advantage is that you're flexible. You can respond to change much more easily than you could in waterfall approach. So this is the idea, is that a little bit of analysis, a little bit of design, coding and implementation and testing happen during each iteration. I want you to think about SpaceX and the way they develop their rockets. Do you think they follow a waterfall approach or a spiral approach to their development? The answers are in my PowerPoint slides, but think before you look. And make sure you check week 1 and the orientation module. The orientation module is labeled Start Here. Thank you.